All right, module 1, what is a coding assistant? And more importantly, why should you care? So before we dive in, let me tell you what we're covering in this module. First, what a coding assistant actually is, and it's not what most people think. Second, the tool use loop. This is the core concept. Once you get this, everything else makes sense. Third, I'm going to show you 4 real demos, not slides about demos, actual simulations of Claude working, Chalk library optimization, Jupyter data analysis, browser automation with Playwright, and a GitHub security review that caught PII exposure. Fourth, we'll look at the real code that powers all of this. You're going to love the typewriter on this one. And fifth, I'll show you how I use this every single day. My morning briefing, my content pipeline, the real stuff. All right, let's get into it. So here's the thing that most people don't realize. Language models, even the really powerful ones like Claude Opus, they can only process text. That's it. They can't actually read a file on your computer. They can't run a command. They can't open a browser, nothing. So you're probably thinking, well, then how does it do all the stuff it does, right? The answer is something called tool use. And this is the key to understanding everything that follows in this training. Here's how it works. You give Claude a task. Claude doesn't just start typing an answer. It thinks about what it needs first. I need to read this file. So it sends a structured request basically saying, hey, Harness, read this file for me. The Harness, that's the Claude Code app running on your machine. It actually reads the file. Then it sends the contents back to Claude as text. Now Claude has context. Then Claude thinks again. Okay, now I need to edit this part. Another structured request. The Harness makes the edit, sends the result back, and this loop keeps going. Think, request, execute, result, until the task is done. This is the tool use loop. And it's not just a technical detail. It's why hooks work, because they intercept at the Harness level between Claude's request and the actual execution. We'll get to that in module 9. So let me show you what this conversation actually looks like between your machine and Claude. On the left, that's your machine, the Harness, the Claude Code app running locally. On the right, that's Claude, the language model. You type your prompt. What's in main.go? Find bugs and fix them. That goes to Claude. Claude thinks and sends back a tool call. Read main.go. That's not Claude reading the file. It's Claude asking your machine to read it. Your machine reads the file, sends back 247 lines of Go code. Now Claude has context. Claude finds a bug on line 42, sends another tool call. Edit, line 42, fix the nil check. Your machine makes the edit. Then Claude wants to verify bash, go test. Your machine runs the tests, all 23 pass. That's the loop. Think, request, execute, result, think again. Every single thing Claude Code does follows this pattern. So here's where it gets interesting. Not all AI models are equal at this, right? Some models are great at generating text, but terrible at knowing when to use a tool and which tool to pick. Claude, and I'm talking Opus, Sonnet, Haiku, is particularly strong at this. Tool use quality is actually one of Claude's core competitive advantages. It's not just that Claude can use tools, it's that Claude is really good at combining them in the right sequence for complex tasks. So what does that mean in practice? Multi-step reasoning. Claude can read 5 files, understand how they relate to each other, then make coordinated changes across all of them. That's not trivial. It's extensible. You can add new tools at any time through MCP servers. We'll cover those in module 7. Claude adapts to use new tools without being retrained. Better security model. This is a big one. Claude searches your code base directly on your machine. It doesn't index your code on some external server. Your code stays on your computer. And let me show you the default tool set. Read, write, edit, glob, grep, bash, agent. These 7 tools are what Claude starts with, but that list grows. MCP servers add tools, hooks add validation layers, and the SDK lets you build entirely new workflows. Now let me show you every tool Claude has access to. There are 16 of them. Agent for launching sub-agents to handle tasks in parallel. Bash for running shell commands. Edit for surgical file edits. Glob for finding files by pattern, grep for searching file contents, then read and write for files, ls for listing directories, multi-edit for making several changes at once, notebook edit and notebook read for Jupyter notebooks, web fetch and web search for the internet, to-do read and to-do write for tracking tasks. That's the default set. But remember, MCP servers add more. Playwright alone adds 20 plus browser tools, and hooks add validation on top of everything. The point is, Claude isn't just a text generator. It has real tools. It can read your code, edit your files, run your tests, search the web, and manage your tasks, all through that same tool use loop. All right, first demo, watch the terminal. Now we type our prompt, analyze the chalk library for performance bottlenecks, and Claude starts working. First tool call, and read, it reads package JSON, 429 million weekly downloads. Then it reads 12 source files, 2,847 lines of code. Next, it creates a benchmark file. That's a write tool call. Then it runs the benchmark with bash. CPU profiler kicks in. And here's where it gets interesting. Claude finds two bottlenecks. The ANSI styles lookup is eating 47% of the time. And there's a string concatenation issue in the template function. So Claude edits, replaces the lookup table with direct property access, switches to an array join pattern, 2 edit tool calls, then it runs the benchmarks again, before 1,047 ops per second, after 4,863 ops per second, 3.9x faster in one session. On the right, you can see every tool call that was used. Read, bash, write, edit, bash. That's the loop in action. Second demo, data analysis with Jupyter notebooks. The prompt, analyze the CSV of video streaming subscribers and find churn patterns. Claude reads the CSV 24,847 rows. Then it creates a Jupyter notebook and starts executing cells. Cell 1, import pandas, load the data. Cell 2, group by subscription month, calculate churn rate, and right away it finds something. Month 3 has a 34% drop off. That's huge. Cell 3 builds a visualization, bar chart saved. Cell 4 segments by plan type. And now we see the root cause. Free trial users have 67% churn at month 3. Paid users, only 12%. Claude's recommendation, the free trial ends at month 3 with no conversion nudge. Add a trial to paid email at day 75. That's read, write, bash, write, read, all chained together. The notebook, the cells, the visualization, all created and executed by Claude. Want to try this? Give Claude any CSV and ask it to create a Jupyter notebook analyzing the trends. Third demo, this one's my favorite. Browser automation with Playwright, the prompt. The button styles don't match the design spec, fix them. Claude takes a screenshot of localhost 3000. That's a Playwright tool call. Then it analyzes what it sees. Background is gray, no border radius. The design spec says green with rounded corners. Claude edits the CSS, background, border radius, color, padding, 4 changes in one edit call. Then it takes another screenshot, compares before and after, buttons now match the spec, font size adjusted, hover state added. Look at the before and after on the right. Gray flat button becomes a polished green rounded button. Claude saw the problem, fixed the code, and verified visually, all automatically. Want to try this? First, add Playwright as an MCP server. Claude MCP, add Playwright npx AR Playwright in our MCP latest. Then ask Claude to screenshot your app and fix something visual. Last demo, and this is the security one. A pull request comes in, add user export to S3. Claude is triggered automatically by the PR. It reads the Terraform config, finds an S3 bucket with a public red ACL. That's a red flag right there. Then it reads the Lambda function. This function exports user ID, email, full name, phone, and home address. And it writes all of that to the public S3 bucket. Claude traces the full data flow. RDS database to Lambdas to S3. Personal data. Flowing to a publicly readable bucket. Anyone with the URL could download it. So Claude posts a security review, PII exposure detected, 3 recommendations, change the ACL to private, hash the email and phone before export, add server-side encryption. This happened automatically on a pull request. No human had to review the Terraform. No human had to trace the data flow. Claude caught it. Want this for your repos? Run /install GitHub app. Claude will auto-review every PR. Now I want to show you what this actually looks like in code. This is from the course's UI Gen project, a real Next.js app that uses Claude's streaming API. Look at this. The stream text function, it takes a model, a system prompt, messages, and tools. Just 2 tools, star replace editor and file manager. With just these 2 tools, Claude builds complete React components from scratch. And see that max steps, 40? That means Claude gets up to 40 think then act cycles per prompt. 40, that's 40 file reads, writes, or command executions, chained together with reasoning between each one. Now look at the tool definition. The star replace editor has 4 commands: view, create, star replace, and insert. This is basically how Claude's edit tool works. The one Carl uses to modify my files every day. It finds the exact string, replaces just that part, surgical edits, not full file rewrites. And the file manager is even simpler. Just rename and delete. But combined with the editor, Claude can do anything. Create new files, reorganize project structure, clean up old code. The key insight here, and this is what I want you to take away, is that the tool definitions are simple. The power comes from Claude's ability to chain them together intelligently. 40 steps of reading, planning, editing, testing. That's not a chatbot, that's a coding partner. All right, so that's the theory. Let me show you how we actually use this every day for real work. Every morning, Carl, that's my Claude Code instance, runs our start operations command, and it kicks off a cascade of tool calls. Read the architecture file, read the command center, read the initialization rules. That's the system brain loading up. Then it runs our morning briefing script, which pulls from 8 different data sources: Google Calendar, Google Drive, Sales Tracker, signups, email inbox, SES Health, AI news feeds, all compiled into one report. That takes me about 6 minutes. An analyst doing that manually, 2 hours minimum. Then there's the intelligence report. That runs on cron overnight, 0 human time. It pulls RSS feeds, analyzes articles, and generates a curated brief. I wake up and it's already there. And then the content pipeline. This is the big one. I give it one article, say, what happened at NVIDIA GTC, and it produces section audio files, a full video, shorts, thumbnails, a YouTube upload, RSS feed update, and a LinkedIn email. 18 plus files from one prompt. That's 15 plus tool calls just for the morning routine. Read, bash, write, glob, read again, write again, bash again, upload. It's the same tool use loop from the course, just applied to real operations instead of demo projects. And that's module 1. Now you know what a coding assistant actually is. It's not a chatbot, it's a language model acting through a tool use loop. And Claude is particularly good at it. Go do the thing. All right, so let's wrap up module 1. Here's what you learned. Claude Code is not a chatbot. It's a language model acting through a tool use loop. Claude thinks, requests a tool, the harness on your machine executes it, sends the result back, and Claude thinks again. That loop is everything. Claude is particularly good at this because of tool use quality. It knows when to read, when to write, when to search, when to run a command, and it chains them together. 40 steps deep if it needs to. And you saw what that looks like in practice. From optimizing a library with 429 million downloads to producing 18 files from a single prompt in my content pipeline. So here's your mission. I want you to open your terminal, type Claude, and ask it to read one file in your project and explain it to you. That's it, just one file. Watch what happens. Watch Claude request the file. Watch the harness read it. Watch the result come back. You're seeing the tool use loop in action for the first time. Once you've done that, you're ready for module 2. Go do the thing.